So, दोस्तों today we are going to start about the phenomena of light, the different natural phenomena of light, and after long back I have met you because of the some personal reason I was a little bit busy in my homework. So sorry for the delay response. But now coming to the phenomena of light, we'll go and discuss about that phenomena. But before going to discussion about the phenomena, you should go and subscribe my channel, and whatever the support required from my side, just put your review on this channel. Accordingly, I will go and I will modify that requirement, and I will share the whatever the concept you have requirement. I will actually go and I will work on that, so that the motto behind of this channel is only to make you more handy and more conceptual on this physics part. So now coming to the phenomena of light, uh, let's go to the particular topic. So where it is? Okay. So the topic is refraction of light through a prism. So we'll discuss about the refraction of light through a prism. So how the prism look like? This is the photograph of the prism. The prism will look like a diamond type structure, you can tell. So we'll discuss about the prism, how the light is passing through prism and how it's diverted in the different, how it's converted in different colors of light. So you have learned how the light gets refracted through the rectangular glass slab, the parallel reflection surface and the glass slabs. The ray when actually coming from the part of from air to entering in the glass. So different the points you need to know, and the points are the that the PE is the incident ray, that the PE is the incident ray, refracted ray, EF is the refracted ray, that the EF is the refracted ray, okay, and FS is the emergent ray, that the emergent ray, the FS. Where is the FS? This is the FS. So this ray is the emergent ray. So we should actually understand about the first the terminology, and the angle of the prism is A. This is the angle of the prism. This is the angle of the prism, and angle of incident is angle of incident, angle of refraction, angle of emergence, or angle of deviations. So these points we need to understand. So what is the angle of incident? So the angle of incident is when a ray coming on any of the surface and we draw a perpendicular line on that particular surface, and the angle between that line and the particular ray, this part. So this is called the angle of incident. And the same way, the another side, if you go there, the particular line and the angle between the ray and the another side is the angle of refraction. And the same way, if you move to the another part, let's see, the same way, when here is the angle and here is the angle. So this is the angle of emergence, the final when coming outside. And the original ray was actually what happened, the original ray was coming this direction and the final ray is diverted in this direction. So the angle between original ray and the final ray, this is the angle of D, that is angle of divergence. So this is the divergence angle. So these parameters you should understand about when you work on this, the phenomena of light. So these are the points. So what are the points here? So we should first understand about the angle of incident, and after that Coming to the refracted ray, that is the refracted ray. EF is the refracted ray. P is the angle of the incident ray, and the I is the angle of incident, and R is the angle of refraction. Now coming to the next point, angle of prism is, this is the angle of prism. This is the angle of prism. So you should also understand about the angle of prism. And the angle of refraction also we have discussed, angle of emergence. So this is the angle of emergence, the final emerging ray that is coming outside from the prism, that is the angle of emergence. And angle of deviations, the original ray direction is this way and the final coming ray direction is this way. So when we draw a line and when we will get, that is the angle of deviations. So the from original to the particular directions after passing through a prism, that is the angle of deviations. So this is one point. We need to understand the different terminology. So you may be in exam you may go through the define and show the diagram of the angle of incident, deviations, angle of emergence, the reflected ray, refracted ray, emergent ray, incident ray, angle of prism, what is the angle of prism. So you must aware about that. Without understanding these, you can't go, and you actually didn't understand. If you don't go through this diagram, you will not understand the exact scenario of the refraction. So now coming to the next point, the dispersion of a white light by a glass prism. So dispersion means disperse. So when you discuss about the dispersion of light, you must have seen the appreciated of the spectacular color of the rainbow. So you have seen that, I think everyone had seen that, we have seen the rainbow, and when we are seeing the rainbow in normal weather you can't see the rainbow. When any rain will happen, after the rain scenario you will see the rainbow. So the how rainbow is happening, let's first go through the prism dispersion via prism, glass prism, and after that we will discuss about the rainbow. So what happening here, when a light is passing through a glass prism, what going, due to the different wavelength means lambda, due to the different wavelength the ray, different ray will be bend different angle. So here the angle of bending angle, if you talk about the divergence angle, so the divergence of the blue light, violet light is more than any other light. So the divergence occurs here. You can see. So you can see from the white light, this is white light, and when the white light passing through a prism, due to the different actually the wavelength of the light, because white light is different combination of different light wavelength. So when the white light passing through a prism, due to the different wavelength of the light is getting bending due to different wavelength. Like the violet light is getting more band and compared to the red light, and the light is due to this different wavelength and bands, the lights are getting separated, and these are the waveguide. You can see here the waveguide violet. You can see it easily the full form of the waveguide. So violet, the first is violet and another is red. Definitely the O is orange, Y is yellow, G is green, B is blue, and I. Let's go through the I also. We'll discuss about that also, the color name. But these are the actually lights color. So the prism is probably split the incident light while the light into the band of the color. Note the color that appear on the 2 inch of the color band, or the sequence of the color that you see on the screen, the various colors seen in violet, indigo. So this is the color of indigo, the second color of indigo. So indigo is the second, after that blue. So violet, indigo, blue, green, yellow, orange and red. And we always listening from our parents, the white light is the combination of 7 lights. So that is the 7 lights of WebGeor. And the band of the color component of the light beams is called its spectrum. The band of the color components of the light beams is called the spectrum. So you should also understand about the spectrum. All you might not see all the color separately, but the splitting of light into the component of color is called the dispersion. We have already discussed about the dispersion. So what happening here, this is called the color distinction, and the splitting of the light is called the dispersion. So you have seen that the white light is dispersed into its 7 color components by a prism. And when we apply the same prism in the reverse direction, the same 7 color will be go and make the white light. We can get it on the screen. We can apply here also screen. We will get the 7 color in the same way. When apply the opposite direction of the prism, we will get the same color. So now coming to the rainbow scenario, what happening here? In rainbow also the same things happening here. What happening here in rainbow? When the light is coming from the atmosphere, the difference of the water droplet act like a small prism. The water droplets act like a small prism, and they are creating the dispersion phenomena. So due to the dispersion phenomena created by the water droplet, I have already told you the rainbow scenario you can't see in the normal weather. It may be possible it will come during the rainy season. So when in rainy season, when light is passing through the air, due to the small droplet of the water droplets, when the light is passing, the water droplets look like the prism, and they are dispersing the white light into the different color. That different color is visible, and we are observing that as the rainbow. Okay. So this is the second point. Now coming to the atmospheric refraction. Refraction also. You should understand what is the atmospheric refraction. Okay. Now coming, you might have observed the appearance of the random wavering of the flickering of the object seen through the turbulent stream of hot air rising above the fire of the radiation. The air just above the fire become the hotter than the further up. The hotter air is lighter or less dense than the cooler air. So the flickering you can see at the just above the fire, you can see there the hotter air. Due to the hotter air we are seeing actually the flickering there, and it is the refractive index slightly less so the hotter air having the less dense refractive index in compared to the cooler air. Since the physical condition of the refracting medium are not stationary, definitely not stationary, because of the few parts of the hotter air and few parts of the cooler air. So the appearance position of the object and swing through the hot air and fluctuation fluctuate. So you may understand my point. So when the light is passing through the low dense medium, low refractive index medium to high refractive index medium, the definitely the device will be show at the flickering way, and this phenomena is also the wavering of the such a effect is atmospheric refraction. So this effect is called as atmospheric refraction. Correct. So and how it happening? It's happening because of the different refractive index of the medium. So when the medium having different refractive index, the device will be, even will see any of the object, and that light is passing through the different refractive index, the device will show as the twinkling or flickering. The actually the twinkling of the star is also the similar phenomena. So when we see the star, so what happening here, the light is passing through the different medium and coming to our eye. This is actually, so coming to our eye, and due to the this different medium, we can see the object, is flickering and twinkling. So that's why the star is, we can tell about the star is twinkling, but in actual it is not twinkling, it's just a stable. Star is one type of planet. So the twinkling of the star is due to the atmospheric refraction of starlight. So when starlight is coming on our eye, that is passing through the different medium, and due to the different medium, the refractive index is happening, and the changing in the refractive index via different medium, and the refraction of the light by a different medium, it is actually the twinkling of the star. And same way, the advanced sun rays and the delay in sunset, this is one of the also phenomena. So the sun is visible to us about 2 minutes before the actual sun rays, and about 2 minutes after the actual sunset. Definitely sun is visible 2 minutes after the actual sun, because of the atmospheric refraction also here. So the advanced sun ray, by actual sun rays we mean the actual crossing of the horizontal by the sun, that is by the actual sun ray, that is actual sun ray. And when we see now, what we see, that actually the sun is here, that we can't see from here, but due to the refraction of different medium, actually the sun is appearing like here to us. We are here, and when we see, we can see here, not down this. But when the sun is getting up, what will happen, due to the atmospheric phenomena, and due to the atmospheric refraction, the actual sun will appear here, not here, when the sun will raise. And the same way, when the sun will setting the sun, so that case the sun will actually go there, but it will show beyond this. So actual sun will be here, but due to the atmospheric refraction, it will go down. So this is the advanced sun rays and delay sunset. Sorry, advanced sun rays and sorry. So advanced sun ray and delay sunset. Yeah, correct. So when sun will go there, the sunset will go there, but due to the atmospheric phenomena, it will look like here. So sun will move from here to, actual sun will move from here to here, but we will observe sun from here, that sun will look here, and when sun will go set here, but that sun will look here. So this is the phenomena of the advanced sun rays and the delay sunset. So a scattering of light. So a scattering of light, the interplay, the light when object around us give the rays of several spectacular phenomena in nature. The blue color of the sky, the color of the water of the deep sea, reading in the sun rays of the sunset, some of the wonderful phenomena are the familiar within the previous class. You have learned about the scattering of light, colloidal particle, that. So actually, what is scattering of light? Why exactly actually our skies look like blue? The molecular of the air and other fine particle, the molecular of air and in other fine particles in the atmosphere have the smaller size than the wavelength of the visible light. There are more effectively scattering light, shorter wavelength of blue ends, and the light longer. So what? So lambda for blue is lesser than lambda for red. So lambda for blue. Let's talk about lambda. Lambda is the wavelength. Is the representation for lambda for blue is always lesser for lambda for red. And the banding of blue is also higher than banding of red. So accordingly, the webviewer we have seen na, so the same way, the banding of blue is higher than banding of red, but lambda of blue is lesser than lambda of blue is lesser than lambda. So everything is actually rotating around lambda. Lambda means wavelength. So lambda of blue is less than lambda of red. So when we'll go and we'll see the banding of blue is higher, yes, surely, because here is the banding of blue and here is the banding of red. So banding of blue is higher. So that's why when we are seeing our sky, so that case the banding of blue is higher, and that we can see our sky clearly. And lambda of blue is lesser, means lesser lambda will give us the more actually the pass through the more area, and the higher lambda will give us the less area, pass through the less area. So coming to the our questions point, there are more effectively in the scattering of light shorter wavelength at the blue end and the lighter to longer wavelength in the red. Yes. So more effective in the blue scattering of light in compared to the more effective in the red. The red light has the wavelength about 1.8 times. This point you need to understand, greater than the blue light wavelength. Thus the wave, when the sunlight passes through the atmosphere, when the sunlight passes through the fine particle in the air, scatter the blue color shorter wavelength more strongly than red. That I have already told you. They will actually disturb the blue light more in compared to the red. The scattered blue light enters to our eye. If the earth had no atmosphere, there would be have been any scattering, then the sky would be look like dark. So due to the atmosphere and due to the scattering phenomena, the blue light is actually reaching to our eye, that is coming from the sun and from a sky, and blue light is actually reaching for our eye, and due to the actually sky is looking like blue, and red light is not that much getting scattered. Due to this we are not observing sky as the red. But if no any sphere will be available, atmosphere will be available around our earth, in such scenario what will happen? The sky will look like a it will look like a dark. So this is all about the our actually the light chapters. Now coming to the Tyndall effect. Tyndall, the earth atmosphere in the heterogeneous mixture of minute particle. We all know the different layer of our earth atmosphere. We all know these particles include the smoke, teeny water drops, suspended particle dust in the molecule of the air. When the beam of light strikes such particle, the path of the beam becomes visible. When beam of light strikes such particle, the part of the beam becomes visible, and the light reaches after being reflected different these particles. The phenomena of scattering of light colliding the particle give up the Tyndall effect, which has so Tyndall effect what? So I can give you the example. So suppose from any particular hole where light is coming, you can see the small particle there, and that from hole we can actually see the ray of light path, that is called the Tyndall effect. So this is all about our light topic, the for class 10th. The entire things whatever need to discuss, I have actually discussed, and whatever the problem you guys will face, no, you just put your view, and what the support required from my side, I will definitely go with you, and I will try to resolve all the issue. And my request to all of you to go your question answers, do the long answer as well as the objective questions also, practice there. I will try to make some questions collections also, and share you in the group and our channel, and you can go and practice there. So this is the end of the light topic from the class 10th. Next topic I will try to go on the electrical part, and I will make a video on the electrical part also, and whatever the supports required from my side, I request all of you just go and share your overview, and my folder handed request is to go and subscribe the channel. So thank you. This is from my side. Thank you.